Okay, good afternoon, everyone. Today's class is mainly for the solution to the test we did together in PHY 001 and 002. That's for test 01. So, which consists of 15 um, multiple choice questions and 2 theory questions. Of those topics, we have physical quantities and units. Then again, we have temperature and its what measurement. So we are going to have solution to those questions. In order to make this very clear to you, let me do this. Hold on. I will have to crop this. So we have question 1. So looking at the screen, we have the very first question here that says that given that a physical quantity has a dimension of ml t raised to the power of -1, you should determine the quantity, the actual quantity. So what do you do? In this case, you have what? You have ml t raised to the power of -1. So if I were you, what I would be thinking of is I could see m, which is, sorry, let me quickly add this person to the class for those joining late. Okay, so like I said, as I mean added. Okay, so like I said, what I will be looking at is the dimension. I have m, which represents what? Mass. Then if you look at what? L_t raised to the power of -1. L_t raised to the power of -1 is, if you look at it carefully, L is for length. The unit of length is what? Meter. Then T is for what? Second. The unit for second is what? I mean, for time is second. So if you look at meter per second, can somebody tell me the quantity you know that represents that? I mean, that is measured in unit per meter per second. Which quantity is it that you know whose unit is meter per second? Anybody? Anybody? Unmute yourself to talk. Good. Speed or velocity? You are correct. So we have this to be velocity. So what's that quantity that is equals to mass times velocity? Mass times velocity. Somebody should answer that. Which quantity is mass times velocity? Momentum. That's correct. So momentum is the answer. Momentum is the answer to that problem. So we choose option B. So not in all cases you can just look at the dimension and tell the quantity. In some cases, especially if it is a bit complex, you will have to find the dimension of each quantity and see the one that align with what the one you have there. For instance, now looking at density, you could have said density is mass over volume. The dimension in that case is going to be m l raised to the power of -3. Now looking at question number 2. Question 2 here says that the thermometric property of a constant volume gas thermometer is changing what? Okay, this one is direct. The answer is what? Changing pressure. I'm sure you can easily answer all those ones. And why is it changing pressure? Because the volume is constant already. You need another property of the gas that can easily change with temperature. And since volume is out, the next thing we could be thinking of is what? Pressure. Number 3 says, one special advantage of alcohol over mercury as a thermometric liquid is what? The answer is low freezing point. The freezing point of alcohol is very low, making it being able to measure very, very low temperature. You know, the freezing point of water is 0 degrees Celsius. So which means when we want to measure temperature that are way negative, we won't be able to use water, for instance, for it. And mercury itself, the freezing point is not as low as that of what? I think is around negative what? 38 or 39 degrees Celsius. While alcohol is about a negative 112 degrees Celsius. So in that case, alcohol becomes a better thermometric property, a better thermometric substance to mercury if the aim is to measure a very low temperature. So the answer there is um, freezing, low freezing point. Now let's look at the next question. Hold on. I'll have to crop this. Okay, now looking at this, the question, that's question number 4. Question number 4 says an object is heated from 30 degrees Celsius to 57 degrees Celsius. The increase in its temperature on the Kelvin scale is what? So the question is asking you for the change in temperature in Kelvin scale. Can somebody unmute himself and tell us what you think the answer is? What do you think the answer is? Okay, 27 degrees Celsius. 27 Kelvin. Does any other person have something different to say? Okay, so, okay, 300. Is that Ayo? Okay, so somebody said 300 and another person said what? 27. The answer is actually 27. Now, let me explain. We have 30 degrees Celsius and 57 degrees Celsius. So, in degrees Celsius, the change in temperature is 27 degrees Celsius. But the change in temperature in degrees Celsius is exactly a change in temperature in Kelvin. This is not me saying Kelvin and degrees Celsius are the same. Of course, a temperature in degrees Celsius is different from that in Kelvin. But if the focus is change in temperature, a change in temperature in Kelvin is exactly a change in temperature in what? Degrees Celsius. So in this case, I have 30 degrees Celsius. If you choose to convert 30 degrees Celsius to Kelvin, that would have been 273 plus what? 30, right? That would have been is that 303? Okay, that would have been 303 Kelvin. The same thing here, 57. If you had added what was it called? 273 to what? To this, that would have been, what would that have been? That would have been 320. Is it 320 or 330? Okay, that would have been 330 Kelvin. So if you choose to do a subtraction there, that's going to give you 27. So change temperature there is 27. Now you don't have to do all this. You just need to know that a change in temperature in Kelvin is exactly a change in temperature in what? In degrees Celsius. I repeat, a change in temperature in Kelvin is the same as what? A change in temperature in degrees Celsius. Alright. Moving on. The next we have, it says which of these is not a vector? We have electric potential gradient, electric potential, you have what? Electric field intensity and temperature gradient. Does anybody want to answer this? I'll wait. Okay, B, right? That's correct. Electric potential. Electric potential gradient is a vector. And one thing you need to always remember is that the gradient of a scalar quantity is a vector quantity. Similarly, temperature gradient is what? A vector. Temperature itself is scalar, making temperature gradient itself a vector. Electric field intensity is also a vector. So the only scalar here, or the only thing that's not a vector here, is electric potential. So the next here is asking you to get the dimension of universal gravitational constant. Okay, let's look at it from here. From F equals to what? G m1 m2 over what? R squared. That's using Newton's law of universal gravitation. Making G the subject is going to be Fr squared over m1 and m2, where F is a force, R is radius or distance, M expressions there mean masses. So the unit of G, merely looking at that, is going to be for force, which is Newton, can be broken down into kilogram meter per second square from mass times acceleration. So the R is going to have what? Meter square, because distance is measured in meter. The masses will be in kilograms, so you have kilogram square. So in that case, using the law of indices, you have kg raised to the power of -1. You have what? M cubed. Then you have what? X raised to the power of -2. So this implies that the dimension for G is going to be equals to, you have M raised to the power of -1, L raised to the power of 3, and T raised to the power of what? -2. You just need to look at the option and tell which one align with what you have there. Now, look at option A, M raised to the power of -1, L cubed raised to the power of -2. That's what look like what we have here. That makes it what? Option A. Number 7. We have it that the values of x, y, and z respectively for this expression for dynamic viscosity. Question is asking you information for dynamic viscosity. So you just need to be reminded that dynamic viscosity now, if we go back to the question, if you are used to dynamic viscosity, you can easily tell what the answer is. Can somebody just tell what the answer is from here? Anybody? What do you think the answer is? No one. Okay. So if you are used to dynamic viscosity, you would know that what the answer is A. For instance, this dimension you are seeing here is the dimension for dynamic viscosity. Don't take my word for it, let me show you. Dynamic viscosity is simply equal to shear stress over velocity gradient. Shear stress over velocity gradient. Or you could say it is equals to shear stress over rate of strain. So either velocity gradient or rate of strain is correct. The symbol that is mostly used is the symbol eta. So we have it as what? If you want to create the unit for eta, the unit of dynamic viscosity is going to be the unit for stress. Stress is force over area, making the unit to be what? Newton per meter square. Velocity gradient means change in velocity over length, making the unit to be per second. If you break down Newton, that's kilogram meter per second square. Then times you have what? Meter raised to the power of minus 2 over s raised to the minus 1. So looking at this, you have kg, you have m raised to the minus 1, and you have s raised to the power of minus 1. So what you have there as the dimension would then be, the dimension is then going to be m, l raised to the minus 1, and t raised to the power of what? Minus 1. So if we go back to that question, it's telling us that m raised to the power of y, m raised by x, l raised by y, and t raised to the power of what? Z. Since we know that we have m raised by 1, l raised by minus 1, and t raised by minus 1, we can from there tell that what? The only answer that aligns there is what? Option A. You get that? So what we have there is option A. So now let's pick the next question. Just hold on. Let me quickly get the question from the source. Copy and paste. Just hold on. We have question 8 to question 15. Alright. Okay. Question 8 to question 15. Okay, I hope the question is not too tiny. If it's too tiny that you can see, please let me know. Okay. So based on what we have here, the very first question is, which of these is not a vector? Oh, this question was repeated. I guess that's a bonus for somebody who knows the answer. That becomes okay. Then question 9. It says the international agreed system of unit for physical measurements are. This one is straightforward. What's the answer? Anybody? C. That's correct. So which is the MKS unit? So the next we have number 10. The moment of a force is dimensionally equivalent to what? Somebody should answer question number 10. Moment is equivalent to what? Power. That's wrong. Not power. Wrong. So the first question you need to ask yourself, what did he say? Actually this option was not supposed to be there. That is that's like tautology. It wasn't supposed to be there. That's an error. So but I'll mark it for those that choose both work. It's meant to be work. Okay, this has to be bonus because even the work was not correctly what spelled. Moment as a unit, moment itself is force. times perpendicular distance. Force times perpendicular distance. Work is force times distance parallel to the force. So what we are interested in here, either perpendicular distance or distance parallel to the force. For unit and dimension, we are less concerned. So the unit for force here is going to be Newton. For distance will be meter. So we have Newton meter. For work as so, the unit for force is Newton, while for distance it's meter, we have Newton meter. So we can tell that dimensionally speaking, moment and work are equivalent. So the same thing for for energy. Energy is just an ability to do work. So work, energy, they have the same unit. They are both measured in joules, but joules can also be written as Newton meter. So which means moment is dimensionally, let me write it here. Moment, yes. All right, ask. No. That perpendicular distance doesn't mean 1 over distance. Perpendicular distance means a distance perpendicular to, in this case, a distance perpendicular to the force. Do you get that? It doesn't mean 1 over. Do you get that? All right. So moment is dimensionally equivalent to work and energy. Moment is dimensionally equivalent to work and energy. So take note of that. And also another thing you need to take note of is impulse. Impulse and momentum. Impulse and momentum are dimensionally equivalent. Dimensionally equivalent. Then another thing you need to take note of is stress, pressure, and modulus of elasticity. Irrespective of the kind of modulus of elasticity we are talking about, be it Young's modulus, shear modulus, or Bock modulus, all of them are dimensionally equivalent. So please take note of of that. So that particular question is going to be made a bonus on the fact that the work was not properly spent. Then look at question 11. It says, from the following options, select the quantity that has the same unit as momentum. What should be the answer, guys? That's correct. Impulse. Question 12 says, at what temperature are the numerical values of the Fahrenheit and Celsius scale equal? Who can answer that? Minus 40 degrees Celsius. That is correct. Minus 40 degrees Celsius is correct. Okay. So let me put that there. That's option B. So either they put minus 40 degrees Celsius or minus 40 Fahrenheit, is the same, because at that temperature they are equivalent. So for the sake of those that were not around when I showed that, Let me show that again. To convert from degrees Celsius to Fahrenheit, the formula is simply 9 over 5 T degrees Celsius plus what? 32. So we are looking at a case where both degree Fahrenheit and degree Celsius are what? Equivalent in value. Let's call that value x. So in that case, you have x equals to 9 over 5 x then plus 32. When you multiply through by 5, you have 5x equals to 9x. Then plus you have 32 times 5, that should be 160. You collect your like terms, 5x minus 9x minus 4x equals to 160. Isolate x by dividing both sides by minus 4, that gives you minus 40. So we have our T degree Fahrenheit is minus 40 degree Fahrenheit. Our T degree Celsius is minus 40 degrees Celsius. So this reveals to us that what? Degrees Celsius and Fahrenheit are going to be the same at minus 40. Moving on. Question 13 says, all are dimensionless except, who can answer question 13? We have relative density, relative humidity, tensile strain, and Young's modulus. Which one do you think is not dimensionless here? Look at it. Which one is not dimensionless there? Anybody? That's correct. Young's modulus is correct. So the rest are dimensionless. Relative density, most time when you see information preceded with relative, when you have something like a relative density, so in this case it's just you having density of a substance over density of another substance. Most time we reference water, because this is already a ratio of density to density. The units are going to cancel out and leaving the quantity relative density not to have what? A unit. The same thing with relative humidity. Relative humidity has no unit. It has no unit. So what we but when you see things like relative velocity, relative acceleration, relative displacement, all those ones have unit too. So let me just note it here. Note most quantities preceded with relative. Most quantity preceded with relative do not have unit. Because most time when you want to get a relative expression, it is by ratio, because you are comparing two things. Exceptions, when you hear relative quantities in motion, relative quantities in motion. Let me be more specific. In relative motion, e.g., speaking of relative displacement, relative velocity, relative acceleration. Any of these, though, I mean, all these ones have units because you are not obtaining them from ratio, you are obtaining them from subtraction. So when you subtract two quantities, the net result is definitely going to have the same unit of what you are subtracting. But when you have a ratio, like a quantity over another, over another, provided they have the same units, they will cancel out. Okay, so moving on to the next question. Question 14. Question 14 says, a constant pressure gas thermometer operates on dash law. Who can answer that? Anybody? Which law governs the operation of a constant pressure gas thermometer? Is it Charles' law? Is it Boyle's law? Is it Gay-Lussac's law or Avogadro's law? Anybody? Boyle's law. Do you agree with the person that says Boyle's law? Any other person? Do you agree with the person? Charles' law. Okay, that's correct. The answer is what Charles' law. And if you can recall that a constant pressure gas thermometer has the pressure to already be constant. The pressure is constant. So which means the only thing that is changing here is volume, and volume with respect to temperature. So if you recall, it is Charles' law that relates the volume of a gas and the absolute temperature, provided the pressure is what? Kept constant. So the answer is what? Charles' law. So Charles' law states that the volume of a given mass of a gas is directly proportional to the absolute temperature, or simply temperature in Kelvin, provided the pressure is kept constant. So the answer there is Charles' law. Okay, so what else? The last question there, which is what? Question 15. Let me mark that. So 15 says Seebeck effect is a what? Is what type of effect? Is it photoelectric? Okay, the answer is thermoelectric. That one is straightforward. So thermoelectric effect simply describe the creation of electric current when two dissimilar metals are when the ends of two dissimilar metals are subjected to different what temperature. So we are going to then move into the theory part of what of this question. Just hold on, let me quickly get the theory part out here. Hold on. So we have sniping 2. Where are you? Okay, just hold on. So we have where's my snipping 2? Just hold on, please. I need to get my 2. It's no longer here. Just hold on. O'Neill. Question 1. Snip. Yes. Okay. Copy. Then paste. So this is a part B of the problems, and here you have what? the very first question, which is question 1. Now if you look at this question, it says define heat and temperature. So heat and temperature, does anybody want to try? Okay, that's correct. Good, that's correct. So she said heat is the energy in transit. Let me write it down. Energy in transit due to temperature difference. Due to temperature difference. So it is definitely a form of energy as a result of what? Temperature difference. So while temperature itself is a measure of the hotness or coldness of a body. So a measure of the degree of hotness or coldness of a body. Coldness of a body. So if you give at least this kind of definition, your full mark, the question just says you should define it. You have your what? 2 marks complete. Then in the next question is asking you to give in tabular form difference between heat and what? 3 differences between heat and what? Temperature. So we want differences between heat and temperature. Anybody? We have heat and we have what? Temperature in tabular form. Okay. Okay, you said heat is a scalar quantity. Why temperature is a what? No, temperature is also a scalar quantity. So you won't be able to hide that one here. If the question I tell you should compare them, are you with me? You can put such as one of your points that heat is scalar and temperature is scalar. But because now the question is a difference between the two, you won't be able to use that. Okay, what else can you use? Okay, units for temperature. SI for temperature is Kelvin. Okay, that's correct. The SI for heat is Joule. So number 2. Okay, I'm listening. I can hear you. You can't see anything on your screen. Oh, just hold on. I don't know why that is so. Let's check. It's showing a blank page. Okay. Let's see. Okay, you know what's gonna happen? Let me stop sharing and reshare. So I'll reshare the screen. Share. So okay, you can see it now, right? Okay. So okay, we measure temperature using thermometer. Thermometer. Oh, sorry. Sorry, I should write this under temperature. Temperature, you measure it using a thermometer. While for heat, you measure using the calorimeter. That's correct. Good. You can put definition. Okay, energy in transit due to temperature difference. Why temperature is the measure of degree of hotness or coldness. Good. So that's correct. Okay, ask your question. I'm listening. Oh yeah, that's correct. Temperature is temperature is fundamental. Why heat is derived. That's correct. Why heat is a derived quantity. Derived quantity. All right. So there is also what they call, this is temperature is a state property. Is a state property. Why it's a state property? Why heat is a process property? Now you may not understand this now until you have done thermodynamics. So, but for now, just take it. Heat is a process property. Why temperature is what? A state property. It's a state property. Alright. So that takes us to the next. So according to what we have here, it says by definition, differentiate between thermometric substance and thermometric properties and give two examples of each. So what are thermometric substance again? Anybody? The definition. That's correct. Any substance that is used within a thermometer that has at least a physical property that can change with what? Temperature. So that's correct. Let me note that here. Thermometric substance. So any substance that has at least one physical quantity that changes with temperature. That changes with temperature. Okay. So give me an example